Yeah, before starting this MATLAB, I should say about my learning and when did I start learning this MATLAB and how I am using this MATLAB, so that you will also have this kind of same interest, or when to, how long will it take to learn, and what is the use. So that is all I can say, share based on my own experience. I came to know about this software MATLAB through one of my students in the time of 1998. Through my student of SVCE named Rishikesh. Of course, the idea of saying this is students are fast in learning the new things. Actually, more than the faculty, students are in the current, always in the current, whereas we are always going to the world. So that point is worth mentioning. And from 1998, of course, it took about some 3-4 months for me to get familiar with this MATLAB, and I slowly started using this MATLAB for solving certain simple problems on the thermodynamic subject. Of course, I started at the same time I started teaching this thermodynamics, and the simple problems like Vander Waals equation or the bubble point, dew point calculations. So such things and all I try to solve using this MATLAB. Of course, with calculator also you can do, but for multi-component systems or for repetitive calculations, these computers are much convenient. Initially I felt Excel is also good. Of course, Excel is still good, but for much more complex problem that cannot be easily solved with Excel, we can definitely try with MATLAB. So this MATLAB learning, whatever I had in that period, say 1998 to 2000, whatever, it took about 2-3 years for me to develop some useful problems. That learning helped me during my PhD time. I did my PhD from IIT Madras during the from 2004 to 9. So in that period, I was of course working on experimental aspect, what is called as photocatalytic degradation of phenol, or is more of kinetic analysis, and something about this getting the concentration data from experiment and analyzing using HPLC. So experimentation and instrumental aspects, and again this processing this data using MATLAB. So this last part was possible because of the learning I had during my teaching at SVC. So during that, because this whatever the learning you have at this stage or at any other point of time will definitely help you in your overall career. So whatever the learning I had at that time, I'm using it regularly. And in the recent 2 years, we also have a course, what is called as a computational programming lab for the third or final year students. So that lab I can handle effectively, all because of the learning I had 20 years ago. And this about my background on MATLAB. This presentation, of course, this MATLAB software is available right from 1990s. I came to know from 1998, and whatever the learning I had it in 1998 is still applicable. That means though they are changing the versions or anything, whatever the code applicable at 1998 is still applicable in even to 2022. So 25 years of thing, there is no change in the fundamentals. Of course, it will be remaining forever. I feel that is a idea of a nice program. Then only the old people or new people, so both can understand this software in a easy way. Okay, coming to this today's discussion in about 1.5 hours or 1 hour 20 minutes time, whatever available. So I need to give an idea about the models, mathematical models, kind of mathematical programs in chemical engineering, and what is how this can be solved with MATLAB. With a typical example problem from chemical engineering. Of course, these problems not specifically for chemical engineering. These are very generic problems. Any other engineers can also easily understand. Say, I know people from biotechnology or any other background may also be available. Let me know. Any of you from biotechnology background or civil engineering background? Any of you available here? If you know, if you are available, please you can at least type in chat. No. Nowadays this interaction is easier through the way of this online platforms. Very silent, huh? Any of you from biotechnology or civil engineering background, at least you can type in chat. I think chat is enabled, no? Automatically enabled. People, yeah. I think I am only talking. Okay, no problem. Say, I assume people are from diverse background, predominantly chemical engineering. So, idea of asking this is the others can also understand without much difficulty. Okay. Coming to this general modeling simulation, of course, these softwares are for solving the mathematical problems. Mathematical problems are, of course, to represent your physics of the problem. Your real world problems, say in the case of chemical engineering, you have the physical explanation of the problem. Say like with increase in height, there is a increase of flow. So these are all the understanding of a system. So these are all represented in terms of mathematical equations, using your Bernoulli equation or mass balance, energy balance equations. So this is the representation of problem in terms of at last mathematical equations. So the mathematical, you know the physics, and you are representing in terms of max. So this max again has to be solved. Then only you'll be having the data. Otherwise, I will be in a position to say about the results, expected results. So for that, we are using this software. So these softwares are very conveniently available. So always it is simply like solving this kind of mathematical equations in your hand calculations. Let's say if you are given with a problem, if the problem is well defined, this software can easily take up this problem and get you the solution. Always, the only thing is we need to know how to give the input and how to understand the output. Okay, we are not going to write very rigorous problem that is expected from a computer science professional. Otherwise, we are just going to use the available tools. The tools are comfortably available. We should know how to give the input and how to get the output. And the next part is about improving your modeling aspect. Otherwise, we need not spend on this solving. This we can work on this modeling. Otherwise, representing the problem in terms of mathematics. That you can fine tune the problem. So there is a whole of this modeling and simulation. That is represent the problem, solve it, and improve the problem, and the cycle continues till the perfection is attained. Of course, let us see about this chemical industry problems. The entire chemical industry problems are, of course, entire industry is surrounded around this reactor. Of course, our own body is also centered around our what is it, digestive system. We have our nice reactor. Of course, what kind of reactor we have? Of course, I cannot wait for the answer. We have this batch reactor, no? Period at least 3-4 hours once we feed the reactor, and it takes about some half an hour, 1 hour, or maximum 3-4 hours to digest. So for this, we have all kind of control system. Okay, we'll understand this chemical engineering reactor now. This reactor, we are having this feeding. You may need to have some feed preparation or pumping the feed to the reactor, and there is a reaction happening, and we need to have a kind of temperature control. So all heat transfer subject will come into play, and of course the reaction is not complete always. There will be always there will be still feed available, or there will be a kind of byproducts getting formed. So all this need to be again separated. So for that we have a separator. So there comes our subject. What is it? Distillation, or say mass transfer, major content, that is distillation. And for understanding all this, we need to have the thermodynamics of the thermodynamics of the system. And okay, again, these products are to be separated, and there is kind of environmental control, and this though the things are varying, we need to control at the near steady state using a suitable control system. So otherwise, we have all these kind of subjects, say ranging from starting from process calculation, fluid mechanics, mechanical operation, thermo, up to economics. So all these subjects are able to understand the chemical industry problems. And we have these kind of equations, namely, what is it? Conservation of mass and energy, and rarely you use momentum. Of course, this momentum conservation normally mechanical and civil people may use, or aerospace. We try to solve in terms of mass and energy itself. And energy and momentum always with energy balance itself, we can solve most of the problem, mass and energy. And equation of state, which is about the connecting the state. The states are simply pressure, volume, temperature of the system. And this equilibrium relationship or rate loss. So these are all the kind of equations will be coming across in our chemical engineering. Of course, the similar kind of equations they may also have in the other engineering as well. Of course, law of conservation of mass and energy, the fundamental equations. Likewise, even thermodynamics also having applications in almost all the engineering, fundamental engineering. So these kind of equations are always in terms of, you want to say this in terms of mathematics. So we are encountering with linear algebraic equations and nonlinear algebraic equations. Of course, many times these are all coupled equations, what is called as simultaneous equations. And sometimes the data are available and you need to fit the data using polynomial or any other nonlinear fit, and interpolating the data based on the available experimental values, and integration, differential. These are the fundamental things, and even partial differential equations and difference equations. So these are all the overall idea of the mathematical problems one is seeing in say chemical engineering especially. And I feel these softwares are good for these chemical engineers. So the very first software I like is Microsoft Excel, which is readily available in all the computers. Of course, more than that, even better, people should know how to use, how to make effective use of your calculator. Even calculator itself, you can solve some of the nonlinear equations. Even matrix problem also can be solved with your handheld calculator also. If you cannot do that, you can try with Excel, and still you cannot if you cannot solve, go for Matlab and Aspen Plus, which is more of chemical engineering process simulation software, which is a slightly different kind, wherein which you have all the data as well. In addition to the models, you also have the data. Okay. And AutoCAD, of course, I feel it is a need for representing this constructional feature of any equipment. And for detailed solution, what is called as three-dimensional solutions, or what is called as detailed solution, we'll normally use computational fluid dynamics. For that, the software like ANSYS, Fluent, these are all good. And for documentation, I feel like this, of course, Microsoft Word people are using for making this document, or Microsoft PowerPoint for presentation. But I feel this software, other software, what is called as LaTeX, which is a free software, is very convenient for highly complex mathematical equations. Of course, I can mention about my book also. This I have, of course, what is it, authored about 3 titles, one on chemical engineering, insight into chemical engineering, another gateway to chemical engineering, and gateway to general aptitude. All these books I had type set with this LaTeX software. So because of this software, this entire book content is only about some less than a KB, always about 2000 pages material. This entire book material is less than 1 MB of contents. That is a source code contents. Otherwise, all these contents are simply plain text, and that will be processed with a compiler, and you'll be getting a nice quality output. So even I suggest you people to learn LaTeX. That will help you to make any research publication or even quality book publications. Okay, this is about the expected softwares. Maybe you people know more about the RISE softwares as well. Maybe I can also get to know about such a thing from you people. Maybe you can type at the end of the session. Okay, or if you want, you can share now also. Okay, this is since we are going to learn about MATLAB, we should also know what are the other alternative commercial or free software. Of course, I need to definitely get your input before proceeding. Can people give idea about other commercial or free software are similar to MATLAB? You know, if I am me alone talking now, it will be again boring. I think my question is clear now. What are the alternative softwares? Thanks for the first Scilab by Ritik, Sri Ritik. Maybe another about a moment, minute, or 30 seconds I can wait. Of course, you know about this nice software in your first year itself, no? first year there is a software programming in your programming course. Used to learn a software. Python, nice. I think Hafiz Muhammad, I suppose. Yeah, right. Ahmad, yeah, right. Thanks, Bob. Yeah, even Python itself is good enough for doing all kind of this processing. Even I came to know about this Python only in the recent years. This what are all the codes, whatever is any logic, I don't know about. Soumya Ranch, sorry, Soumya. Thanks, Ma. I'll note about this. Yeah, of course, I will have these recordings and I'll see this later as well. Thanks for saying about this other software. Some more softwares, maybe Scilab, Python. These are all free tools. I don't know about any logic. Any other commercial software, as like Matlab. Okay, we can differ for some time. Thanks for the response. Of course, I have written something. Maple, Mathematica. These are all the commercial softwares. And of course, I haven't written this about Python. Of course, Octave, Scilab, SageMath. Even I should add the other software. No, what is it? This Python is even having similar feature, almost quite similar feature as that of Matlab that I haven't added in this slide. I should add this. Of course, this slide was prepared slightly earlier. Okay. Let us know about this software. We should also, whenever you learn any software, you should also know other such softwares. That's why the question was. Okay, the other, okay, about MATLAB, this software has started sometime in 1970. It so originally maybe written in, I think, Fortran codes, I suppose. It became a commercial company sometime in 1984 itself. And 2000, by 2000, almost every people in the academic started to feel always speak about MATLAB. Of course, I also came to know about this in the year of roughly about 2000 or 90, I am not sure, 98 to 2000. And by 2020, about 4 million users across the industry. Of course, this name is Matrix Laboratory. You may ask why to study about only matrix. Though mathematics is all about not only matrix, it has a lot of other features. Why it is named as Matrix Laboratory? Can any of you answer this? Of course, I'm going to answer it shortly. Why it is named as MATLAB? Of course, why it is to be centered around matrix? Okay, this matrices and arrays are heart of MATLAB. It has programming features similar to any other OOPS software. Okay, like C or C++ or Java. It also has similar programming features, but normally not used in that perspective. We are trying to use this for mathematical problems. The idea of this name is all these problems, any mathematical problem, at last can be represented in types of matrix. Say if you have a set of differential equations, that differential equations also can be converted into difference equations, and again it is simply linear set of equations, or any partial differential. At last everything is set of linear equations. Matrix is trying to solve them in terms of linear equations. So that's why this even in real numerical solution technique also, people try to convert all these codes in terms of all these equations in terms of linear set of equations. Once you have linear set of equations, you can solve easily, because we know how to solve linear set of equation using MATLAB, using matrix. Say we try to take inverse, or we will check whether the equations are consistent by checking the rank of the matrix. So these are all some idea. So that's why this name is nicely termed, coined, MATLAB. Matrix Laboratory. Okay, it provides extensive numerical resources and consists of reliable, accurate, because 20 ways people have tested this feature. So definitely you can take the code for take for guarantee, and you can solve all kind of mathematics. And most of the time we'll try to solve using this terminal. Then in the terminal itself, we'll write a code, or we'll be having set of lines and called in the terminal. And it is also having a graphical user interface, what is called a Simulink, which is very good for this solving using a block diagram representation. Normally for process control, this symboling is very convenient. Of course, this is also a part of MATLAB. So there is symboling is not a separate software, which is a part of MATLAB, runs over and above MATLAB. Okay, coming to the MATLAB, even I already had installed MATLAB. Of course, my MATLAB screen is visible now. CLC for clearing the screen. Of course, I'm not going to give demonstration since I am sharing this screen. Instead of showing this thing, I can show you live. So there are if you have properly installed, and you will be seeing this menu. Say this menu, which is there is a cursor blinking. No, there is a command window. So this window is to type any commands you can process. And the other thing is workspace window. Of course, this command window alone is the essential window. Other things are just for another display. You can even close them if you don't have enough space in the main area. And these are all just to see the commands we executed. This and all you can clear also if you don't need. So, okay, I think you can clear them. Oh, fine. Likewise, these are all. This is saying about the variables in the current workspace. Of course, once you close this MATLAB, this workspace variable will be lost. If you want to save them, you have to save it in a separate data file. And these are all what is called as a file. They are in the current folder. Of course, you can change the folder. These are all your Windows operations. Okay, and any other things you can. So, and if you want to know in detail about any command help, you can use this help commands. Okay, a lot of things are available. You can type and you can open this browser and other thing. Okay, coming back to the presentation. So the command window is the essential window. Other things are for you to interact. Say, for example, these are all simple set of instructions. Say, for example, 2 plus 2. Say whatever you want to do. As like a calculator, you can use this too. So sign off to. So these are all very well available in a calculator itself. So that and all you can easily try, but it has more feature than a simple calculator. Say for example, these things you can process easily, and you can easily input a array. Say for example, 1 to 10. That means you are giving this data of 10 numbers with a simple description. So this array processing, array inputting, array processing, these are all quite easier. So since we have limited time, I cannot give a demonstration, but as and when very essential, I will go to the MATLAB window. Okay. Otherwise, I will be sticking to this presentations material. Yeah, here I am using this color code. Say whatever the input are given in this blue color, no? And once you type, you'll be getting this output. Say for example, so CLC for clearing the screen. Say I'm typing this D equal to 2. As and when you type, MATLAB is again echoing this result. That means D is assigned with 2. Otherwise, you have a variable what is called as D. So you can see this D. This is a variable, and there is already a default variable what is called as ans, which we were using it earlier. You can, if you want, you can remove them. Okay. So so whatever I am inputting is given in this blue color, and the output is given in the red color. Okay, this is a color code I am using in my presentation. And this double greater than symbol is for this MATLAB command win. What is a command prompt? Okay. And here see D, I am typing and I am getting the output, and V I am getting. Say for example, again row equal to 1000, and yes, using a semicolon. Say suppose some variable you want to assign, and put some semicolon after that. This semicolon is actually preventing the echoing of the result. Of course, row is assigned with 1000. You can see this. Even you can, if you want to know these variables, what are the variables available, you can simply type who. So what are all available, you can get to know. And what is the value of the variables, you can simply type them and get to know. Otherwise, also they are available in this workspace window. Okay. So whereas if you want to suppress the echoing of results, say for example, let us assign this mu equal to 0.001. If you type simply, it will again give this output, of course, in a different in a formatted way. If you want to if you want to change, okay, you can change it, of course. Point not one. Okay, here it is assigned with a value, but it is not echoed in the terminal. That is, service semicolon is having the role of suppressing the echoing of result. Okay, that is one point we are now saying. And the semicolon is also having other role that we will see shortly. And you can easily input a complex number. Say, whereas this in your calculator you cannot implement this commercial what is it? You cannot easily give a complex number input, and also you cannot get a complex number output. Even with Excel also, I'm not sure whether you will be getting a complex number. So this getting or even the C programming, you cannot easily handle a complex number. So these things can be easily inputted, or you can easily get the complex number processing using MATLAB. Say for to input a complex number, say what we are doing, we are simply having a variable C1 which is equal to 2 plus 3i. So this I represents indicates this is a complex number. In addition to I, you can also use j. Say for example, let us have a complex number. So a equal to 1 plus 2j. It is actually taking as I and j are reserved for complex numbers. Okay. So these things are inbuilt thing. Automatically you can process easily, you can process complex numbers. So these are the default variables ans and pi. If you type, it is taking the value of pi. Say for example pi, it is giving the value of pi, and inf, it stands for this anything 1 by 0 form, anything by 0 form, and not a number. These are all normally available in even calculator itself. Okay. And you can handle use all kind of mathematical functions. So whatever the function you have, your thing coming across or thinking in mind, you can definitely try that in MATLAB. Say for example absolute of -2. Fine. So this is readily available. Okay, so far we are processing only with this simple number or simple variable. What will the command? Okay, this and all I don't have time. You can change the format from the usual format to any long format or short format. There are variety of options that you can try. And you can look for help for any specific command using this command, like what is called as look for or help or DOC or simply Google. No? Now Google is available for anything. So we need not spend time on that. And now let us go to this processing array operations. So far we are saying about simple variable. And again, I forgot to mention about one thing. This any variable naming is alphanumeric starting with alphabet. Okay. Otherwise, any variable is simply, say even a is a variable. Say let us assign this a equal to 8 or a b1 equal to 10. You can simply process a plus b1. Fine. So this variable naming is alphanumeric and starts with alphabet. Okay. This is similar to any programming language. And now let us process this arrays. So yeah, let us see x equal to 1 to 10. What is the meaning of that? X 1 colon 10. The colon says about range. And 10 starting number is 1 and ending number is 10. So what is in what increment we should take? So the default it will take it as the one increment. Let's say 1, 2, 3, 4, 5 up to 10 it is taking, including 10. And y equal to sign of x. So that means every value of x will be taken a sign. So here we are not writing any for command or anything. This x is a array variable and y is a array output. So normally for doing this with any other programming language, we are supposed to have what is it? Some for loop. So such a requirement is not there because MATLAB is automatically accepting any matrix input. Here it is simply a one-dimensional array. Matrix is a two-dimensional array. Even two-dimensional array also can be easily handled in MATLAB. So y equal to sign of x, and it is giving this result. And okay, now how to extract specific element of a matrix, element of a array? Of course, matrix is also an array. Okay, so how to extract specific element of a array? So y of 3 means third element. So third element is this 0.141. Or suppose you want to get 1 to 5 of y, you can specify this. Okay, now the question is, suppose I want to have an array with a different increment. So what can we do? What can be done? Simply let us check this. X equal to 1 to 10. It's giving this way. Let me clear this. And x equal to say 0 to 2 to 10, which means starting 0, ending up to 10, ending at 10, and with the increment of 2. You can also have negative increment as well. Say y equal to 10 minus 2, 0. So these are all now, okay, I have to say about this structure. So starting number, ending number, and initial the middle one is the increment. So if you don't specify this increment, it is taking the linear increment. Okay, this is enough. 1 to 10, starting and ending is enough. If you want to have a linear of 1 increment. Otherwise, you need to specify the incrementing thing by introducing the other. Okay, what is it? By this way, have this one more colon, and the middle one is to say about the increment or decrement, whatever. Fine. Now, so we processed one-dimensional array. Now let us go for two-dimensional array. So far, so good. We could understand one-dimensional array. Now, two-dimensional, slightly increasing. So what we are giving, A is 1, 1, 2, and this semicolon is also now ending a row. Earlier, we were using semicolon to what is it? Suppressing the echoing of result. Now a matrix is defined using this 1, 2, and a semicolon again 3, 4. So maybe I will try this directly. A equal to 1, 2. Okay, arrays to start a matrix, start with square bracket, and if you simply press enter, also it will accept 2, 3. So 2 and 3 are in the first row, and 1 and 3 are in the 1 and 4 are in the second row. And to end it, you have to have this. So this is matrix input. Of course, this is we are spending too much of space. Instead, we can do this simply from this in a single line itself using this semicolon options. No? Semicolon is to end a row, and this semicolon is now to prevent the suppressing, prevent the echoing of results. Otherwise, say, let us understand, do it again. CLC, so let us have this B equal to 1 minus 1, whatever, 2, 0, 3, minus 9. Okay. And say, for example, so this semicolon is to end a row, and what this semicolon is actually to suppress the echoing of result. So that's why we don't have this B getting echoed in the terminal. Again, if you want to see the result, B is this way. Fine. Otherwise, say the characters are having multiple roles. Say the semicolon not only to suppressing the echoing of results, it is also to end a row. That is a thing to be now taken into mind. Okay. And say the normal concatenation of matrix. So A and B are two matrices, and A of the same size, and the concatenated matrix is available this way. This is normally used to do in this normal mathematical solving. So this is automatically available, and ANS is the default variable, I should say. Even your calculator also has this default variable of ANS. No? If you don't assign anything, it will be assigned to ANS variable, and you can recall them also. So ANS is a 2 by 4 matrix, 4 rows and 4 columns, and ANS minus 1. ANS minus 1 means ANS and ones of size ANS. Every element of ANS is subtracted with 1, and you are having this another ANS. The default, since we don't assign this ANS minus 1 to any variable, and the another ANS is now altered. The default result is ANS variable. Okay, there is a thing. And here A equal to C equal to AB, and yeah, how to extract specific element of a matrix. Say, for example, we want to process only the output, only the first row of the C. So for that, how to get? So C of 1 comma colon. So colon earlier we were using to specify the range. Now this colon is having the meaning of all. In what way? So we are getting this first row and all the columns. So C of, let me type and explain this. So let us have some matrix. We were having A and B of different sizes. No? So let us clear this and let us have a C matrix. I can simply type this. Okay, we have this C. So how to get C of always first row alone, first row and all the columns. So we can simply type this way. Sorry, we'll get the thing, a code in the terminal. So C of 1 comma colon is simply this result, no? Which is assigned to ANS. If you want to assign to any other thing, service, what you can do. So D equal to C of second row, or let's try with other way. All the rows and first column. So what is the expected output? Can any of you say? What is the thing expected? So otherwise, if I am speaking monotonously, I will be. So it is about inputting and outputting matrices. And why we need to spend on matrix? Because all the data are at last available in the form of one-dimensional or two-dimensional array. So we'll definitely go to nice aspects of, better aspects of MATLAB, but we need to know about this data processing. So what is the expected outcome for this statement? D equal to C of colon comma 1. Yeah, nice. Thanks for that thing. I think I need to give some rewards for these people. Who has done that? 132. Sorry, I would not see the name because of the Akshut. Sorry, I could not. Akshuta. Yeah, sorry. 132. Nice. 132. Let us fine. Check it. Fine. Nice one. Thanks for the response. Like this kind of, because otherwise it will be boring to the people. I should also ensure that you people are learning really, are following. Okay. C of 1 and okay, colon is now understandable. Colon is having the meaning of all, but here this colon is having a now different role here. C of colon comma colon is first identifier is for the row, second one is for the column. So C of 1 means first row, and comma after that it is column. Column is all the columns. So we have this 1 2 1 1, and now I want to get all the rows and second to last column. So I don't know the last column number, or is I don't know the size of the C matrix. I can simply have this use this variable, built-in variable, what is called as end. End is a keyword or the built-in thing. So C of C colon comma 2 to end. So 2 to end, or is this is the expected region. No? I can get this thing. So what is the thing? So this is the expected region. So second, all the rows and second to last column. So you'll be getting this output. Fine. Okay, this way we need to deal with what is it? Of course, inputting a matrix is understandable, and suppose you have the matrix output. So which elements are to be processed, or which you want to use it for that and all. You need to know these kind of simple this matrix deal with how to do the matrix operations. So now let us go to the small quiz. Already we have also put up a quiz. So what is 2 A of 2 comma 4? Simple mathematics, nothing, no MATLAB. 2 comma 4. What is 2 comma 4? I need not ask for the answer. So second row and the fourth column. Yeah. Sorry, second row and fourth column is supposed to be 8. Fine. So matrix functions. Now let us go to the interesting features. Matrix functions. All these functions are readily available. What is called as determinant of A or inverse of A. You need not write any rigorous for I loop. You can simply have this make use of these built-in functions: determinant, inverse, upper triangular, lower triangular, or rank, size. All these you can try. Eigenvalue, eigenvector, all kind of mathematical functions, whatever you have in your mind or whatever you'll be coming across. That you can easily process. Okay, now the essential next another essential aspect is there. What is called as using what is called as element by element operation. Suppose you have one row, one column, and it has to be multiplied with another column. So how to do that? Normally everything is a matrix data. So you will be having say one row, sorry, what is it? One column and 10 rows, which means 1 into 10 matrix you have. And likewise, you want to multiply the same thing with another 1 into 10. The normal matrix operation is actually matrix multiplication. So 1 into 10 cannot be multiplied with 1 into 10. Correct, no? So for any matrix thing, so if you have a 1 by 10 matrix, it has to be processed with 10 by 1 matrix to get 1 into 1 matrix. So any operation, say like multiplication, division, or addition, subtraction operation, everything is matrix operation by default. But if you want to ensure what is called as element by element operation, we need to use a symbol called as dot. So this dot is having such a nice role to play in MATLAB. Say for example, A equal to this matrix we have. Sorry, I need to suppress this sound. Fine. Yeah. So this A and B, you know, this we are expecting only this 1 to be multiplied with 1 and 3 to be multiplied with 2. So you'll be getting, you are expecting this result. To do that, actually you need to use A dot, or you need to prefix this operator with dot. So the operation is multiplication. So if you try to do simply A dot A star B, you will be getting matrix multiplication, which is the result is supposed to be this one. Whereas we are now looking for, suppose we are looking for this kind of operation, what is called as element by element operation. So we need to make use of this dot. Of course, most of the MATLAB problems normally are if you are if it is having some difficulty in compiling, the mistake people are committed by people is simply this misuse of dot. Sometimes you forget to use this dot. That will end up with error. Okay, please keep this in mind. The dot is having such a role to play. So already we have seen about semicolon, and also we know about the colon, and the next major thing is dot. Okay, and comma, of course I haven't said about comma. Comma is also used. Whereas comma normally we normally not use. Let us see about comma as well. No, comma is, say for example, you want to have A equal to, you can also say like 1 comma 2, which is also equal to A equal to 1 space 2 also. Otherwise, this space is also doing the role of comma. That's why we normally don't use this comma. Otherwise, comma and space are having the same role to what is it? Separate the entries. Okay. Otherwise, this semicolon is having a role of ending a suppressing the echoing of result or ending a row, and colon is meaning is used for specifying the range or having the meaning of all, and dot is having the role of making element by element operation. Of course, these element by element operations are needed mainly for this, what is it, multiplication and division. Whereas for plus and minus, normally we'll do only this element by element operation. Right now, for any matrix multiplication, sorry, matrix addition or subtraction, we'll subtract with the corresponding element. Say A minus B means we'll try to subtract this 1 with 1, or 3 minus 2. That only we'll do. Whereas only for this multiplication or division, we have this different way. No? The row and column way we'll try to do this. We know about this matrix multiplication and matrix divisions. So that rule is normally taken to instruct MATLAB not to do this matrix multiplication or matrix division, or to get this element by element operation, we need to use dot prior to the operator. So in addition to multiplication and division, we also have the other operations like even taking the power, exponent, that also have requires you to use dot. Okay, that and all you can explore later, no problem. Say for example, we have this A and B, and trying to get element by element multiplication, we know this result. Suppose you are trying to get A by B. So A by B, I am getting this error. Reason is this B is a singular matrix. Determinant of B is 0. because 1 into 2, 2 minus 2, so you have 0. That's why you are getting this error. Of course, we are also seeing what is a by b. Whereas if you are interested in a dot slash b, this is for element by element operation, a by b. Okay. Okay. To quickly recall, we have seen about matrix processing. That is how to input a matrix and how to get how to extract specific elements of a matrix, and we know about these matrix functions and the essential aspect, which is what is called as element by element operation. For element by element operation, we need to use the dot prior to the operator. So in the case of multiplication or division or taking exponent or maybe any other things may be there. For plus and minus, this normal matrix subtraction and addition is enough, because that's what we are doing in matrix operations. Okay, any of you can try this, how to get this y equal to. Of course, you can write a lengthy code making use of for I loop, but in MATLAB, you can write this, you can get this output in a single line of coding. Okay, it may be delaying. If you try this to solve other way, I'll give you this output. No? Say, for example, simply you can type this way. There is a built-in variable what is called as sum, and 1 dot. So we are going to divide this every 1 divide by 1 to 50. Of course, each and every element of this 1 to 50 is to be taken a power. Or is this simple line of thing, no? Single line is enough to get this output. So in that way, MATLAB is very powerful. Whereas if you want to do this with any your fundamental programming like with like C or any other thing, you have to write for I equal to 1 to 50, do this operation and add the things and get the outputs. Of course, in MATLAB also you can try this way. So x equal to 1 to 50, y equal to 1 divided by x to the power 2. And why we need to use this dot here? Because again, x is a array and y is also will be array. Y is also to be array, and since 1 by x means arrays, we need to have every element of x to be taken as square, and we have to get this thing plus ordered. So you will be having a y also as a array, and sum y means all the elements of y will be summed up. So you can write these 3 lines or write some 10 lines in your C or any other programming language, or even a single line of MATLAB code. This is also enough. Here we haven't used any other variable. Here we are using x and y and making this another variable, which is ands. Okay. Good, no? Otherwise, MATLAB is such a nice programming language. Otherwise, you can minimize the number of codings. Okay, so far we are trying to process everything with command line. But for a large program and all, we can write these things in separate file, text file. That file can be called in the run prompt and can be processed at once. Say, for example, yeah, simple programming. Of course, people can understand. You people can easily understand. I'll take some water. How about so far? Is it going on nice? I need to take your feedback. I'll have some water in the meantime. So about 50 minutes, we could do only see only the minimum basic features. Another about 30 minutes, we'll see very nice features. Now only we are just starting into handling this service, how to input to the matrix MATLAB using a set of instructions. What is called a set of programs, or people used to say like a script file or function or is it M file simply, or is this file is simply a plain text contents. We have a editor available in MATLAB itself, so we can new script. So this and all you can use it for typing these contents. Okay, that and all you can try. I'll simply say. So you can type these contents in a plain text file, and you can call this thing if the file is available in your current working directory. You can simply type the file name without the extension. Of course, you need to have the extension in the name of M. This .m file will be automatically processed in Mat. Of course, I can also try to do this, but it will take time. I need to cover some more thing. This idea of this class is to give you an overall view of Matlab, not the demonstration. This demonstration you can try. Of course, whatever the material available, I will give you in the form of a handout, maybe shared at the end of this session. You can get it from your coordinators. Some 5-6 page content that you can try yourself by typing yourself. Then definitely in a period of about 1 month, definitely you'll be getting a good feel of using Matlab. Okay, coming back, we are using this percentage. What is the role of percentage? Of course, you can easily guess. It is having the role of what is it? Commenting on the line. Commenting. Of course, I have done this in 2001, and even recently done in 2011, and even the same lines is also working now. For the 25 years, the same I'm living with this same thing for the 25 years. Of course, Matlab is that's whatever the earlier the same codes are still working. That's the idea of saying this. Okay, say let us understand this. We have this new thing what is called as input. Say the input, it's a built-in function or variable. We can name it whatever the way. So input function or input variable. Sorry, input command. Input command. We have something in the single braces. So this is for our own idea. So this is the contents, and if it is getting processed, it is dia in meter. It is asking for the data from the user. Otherwise, input is to get the data from the terminal by the user. Otherwise, the user has to input the data. Say for example, dia in meter, it is asking. I am inputting 0.1, and velocity in meter per second, I am inputting 2. So these are all because of these input statements, and these data are assigned to D and V. And already I have rho and mu assigned. Of course, rho is for the density of water, or mu for this density of viscosity of water. And I am having this command Re equal to dV rho mu. Simple, no? Simple command. Any people can understand this line. And I have another thing processed, what is called as F equal to 0.079 Reynolds number to the power minus 0.25. Of course, people from chemical engineering know about this equation name. So what is Re? Re is Reynolds number, okay. And what is this equation? F equal to 0.079. Any people in, of course, people in the third year are supposed to know this, say this. Okay, Re is calculated, and F is again calculated. And say I'm if I don't have this semicolon, F will also be getting displayed. But I am using another thing, DASP. Otherwise, DASP is doing the role of always without having any semicolon. Otherwise, if we have a semicolon, the result is not echoed. Whereas here I don't have semicolon, I'm getting this result automatically. So this value is supposed to be the value of DASPF. Okay. This everything is available in your handout. I will be giving it. Maybe I can show you the handout so that how it is looking like. Okay, this all these contents are concisely given. So about some 6-7 page, you can maybe take a you can try this. Take a printout and type this yourself and get this done. Okay, all these contents are available here. Okay, going back to the presentation. Matlab, what is it? Where we are? Sorry. Fine. Fine. So this is what is called as this is called as a script file. So it is called as always all the contents you are writing in a file. Here we don't have any function or any other usage. Some built-in functions are we are adding some variables, doing some calculations. Instead of typing this in the command terminal, the command prompt one by one, we are doing this separately in a text file, and this file is called through the this from the command prompt. In the command prompt, simply type the file name. So I have this file name friction factor.m, file friction factor.m available in the current working directory, which is supposed to be m files. Of course, you can have in your own name, whatever the name. You can change the working directory. These are all simply DOS commands or WAD commands. Okay, and we need not say much about that. And if the file is available in the current working directory, you can easily type that file and it will be processed and you are getting this output. And sometimes, okay, we have a lot of built-in variables. Sometimes you want to define your own variables. Say in this case, say for example, I am interested in getting the value of RE or F for many values of DV, rho, mu. So for every time I need not change this thing. Instead, I can make you simply call this file what is called as flow and input that input DV, rho, mu. Of course, you know about this usage based on your idea of any programming language. So we are making defining a function file, what is called as flow.m. Of course, the file name is automatically based on the function name. Okay, as and when you start typing, maybe I will copy this and show you how it is coming. There is some error, something. Okay, so how to do this? You can go to new function. Already it is giving some structure. You can clear them if you want. And if you try to save this, sorry, it is saying like, wait, fine. So if you try to save this, it is automatically saving in the name of, say the, what is it, function name. Or is the file name and function name are the same. Since I already have the same name, I need not have this now. Okay. So are you able to understand? Now I think it's understandable. I need not ask for your input. Say for example, how the usage. Say I have this DV, rho, mu given in the order, and for the file, the function flow is taking that variables and it is doing the processing, and it is getting the output RE1 and F1. So you can, for any complex thing, you can write a function file, and that can be used as and when needed. Okay, as like any programming language, you have also the control flow statements. Of course, for I loop is not very needed for simple array operations. But again, if you have so many arrays to be processed or a lot of other checks to be done, then you can make use of these useful control flow statements available in any programming language. Say for loop, you people may be knowing easily, and if some expression, and if it is correct, and do this, or else you do that, or while operations or switch case statements. So as like any programming language, MATLAB also has that. Okay. And okay, some small quiz, people can answer this. So I'm typing x equal to 10, and the next statement I am using 5x. It is giving some error. So what is the reason for this mistake, error? I need to ask you people input also, no? So what could be the?
I've used a semicolon, sir.
Semicolon, not semicolon is not necessary, no? Semicolon, if it is used.
Star X, sir.
Semicolon.
Star X.
Which one? 5
star X.
Yeah, correct. Who said that? Sorry, I am meant to see you people. 5 star X. Yeah, 5. Mohammed 5. Thanks, Pa. Thanks for closely following. I think many people also would have guessed the answer. Fine. Okay, good. And the other thing, okay, semicolon is normally to suppressing the echoing of result. Okay. Of course, X is assigned with 10, and 5x, if you have semicolon, the output 5x will be available, but here 5 star X. Okay. The mistake is actually 5 star X, because as like you are writing, you cannot simply give us input. We know this 5x means 5 into x, but MATLAB need to be instructed with star symbol. Okay, nice, good. Thanks for the input by both the people. Okay. Okay, this and all you can easily do. Now, okay, so far we have seen the basic aspects, what is called as matrix of array processing, matrix processing, inputting outputting specific elements of a matrix, and doing matrix multiplication, division, all the things, and writing this contents in a script file and processing them, or writing your own function. So these are all the things normally available in any programming language. Maybe some functions may not be readily available, like a function to solve complex number may not be available, but the most of the features are also available in any other programming language. But MATLAB is still much more convenient than any other programming language for our mathematical solving. So now we are going to see the engineering problems, solving engineering problems with simple examples. Okay, to start with, we are going to see the plot, how to do plot operations. Of course, for plotting, we are having a convenient tool, Microsoft Excel. But Microsoft Excel, okay, good for thing, but suppose you want to do repetitively the same kind of thing, that and all easily possible only with MATLAB. So let us understand this. X equal to 1 to 50 and y equal to x dot square and plot x comma y. So we'll try this at least. How much time? Another about 20 good minutes are there. Let us try this. Let me clear everything, and I'll clear this other variable windows. And if you don't need any other window, also you can reduce the size for that thing. Okay. So let us see some plotting. X equal to 1 to 10. Yeah, and y equal to let us make a polynomial. So what is square x square y equal to x dot square. What is the meaning of that? Every element of x will be taken as square, and simply plot x comma y. This is enough for making a plot. I should get the plot coming now. Where is that plot? Yeah, coming. See, you can get the plot easily. Of course, you want to make this label for x-axis, y-axis, that and all you can try. That and all available in the various other features. Okay, what is called as x label, y label. So whatever the text you want to appear here are that and all you can give, and how the points are to be marked. That and all specified this way. Always the minimum thing is plot. You need to give x and y, and plot x comma y. That is enough. The other things are optional. Whereas plot is expecting these two variables. The third variable is actually an optional thing. The third thing is saying about how to mark the points and how to connect the points, or even you can also add how to color the things. So these are all available. You can explore them simply by typing help plot. Okay, or you can Google. So here you will also given with the example how to do this. So these are all you can try. Fine. Okay, good. Okay, this is readily available. How to make a log-log plot. So log-log plot. Okay, let us see a simple plot for f versus Reynolds number. So I have this simple equation 0.079 RE to the power minus 0.25. See here, RE is available in a range ranging from 10 power 3 to 10 power 7. Is 1000 to what is it? I couldn't understand. 1 crore. No? So such data we need to have. Of course, I don't have the data, but I am giving this data in the form of a logarithmically spaced, uniformly spaced data. So, what is the meaning of this log space? Whereas P is actually RE. If you want to assign in terms of this RE and F, here P and Q, RE and F. Okay. The people of chemical that they can easily, chemical or civil or mechanical, they can easily understand this. This log space 10 power 3, this is actually 10 power 3 to 10 power 7. Log space are logarithmically spaced variables starting from 10 power 3 to 10 power 7. And here Q equal to every element of P taken to the power of minus 0.25. That's why we have dot. And here we don't have any dot because 0.079 is simply a scalar, whereas this is a array or vector. No? And log of P comma Q, that is enough. And this is about how to mark the points with the dot and how to connect the points with a smooth line, that is a dash. And having this grid to show these grid lines. Okay, this and all you can try. Log space is, sorry, we have simply log. We can also try, you can also try semilog X, semilog Y for you to get semilog plots. That and all having quite applications in your process control frequency response studies, no? Okay, or Bode plot. Okay, how to make this plot? So I can define x ranging from 0 to 10 and y equal to sine of x and plot. Yeah, simply plot 0 to 10 with the increment of 0.1. So that's what we have now. We have every 0.1 interval, we have this marking and sine of the same thing. Of course, here if you have a variable that can be assigned here, and points are marked with star, and x label, y label, title. So everything, these are all possible from these two lines of codes. Good now? Okay, now let us see this multiple linear equations. Of course, multiple linear equations already we have come across in the form of solving this matrix or using this inverse or rank or any other operations. So simple example is available here that you can try later. So I need not spend time for that. So now we have this interesting thing, what is called as processing nonlinear algebraic equation. So nonlinear algebraic equation, let us take a single equation. So we have this equation 5 minus 2x equal to exponential of minus 0.25x, some nonlinear expression. We want to solve, or solving means getting the value of x which is satisfying the equation. So otherwise we need to write this in the form of f of x equal to 0 form, otherwise rearrange to this form so that right hand side is equal to 0. And this is to be inputted to the matrix in the way of a function file. So we are writing a separate function file. Function, the output of the function is y, and the function name is fcnnle1. You can name it in whatever the way. It is inputting, taking the input of x. So for every x, it is calculating this value of y, and y is the output of this function. Yeah, simply this line is implemented here, written here in such a way that y equal to 0 form. And you are going to solve this equation by making use of the built-in matrix Matlab function, what is called as f0. So f0, always, how do you solve your nonlinear expression? You know this Newton-Raphson method, the most used technique. You'll be writing the function and trying to give an initial guess. Once you always, if you start with the initial guess, you can keep on process, and finally you'll be getting a converged solution. So we are starting with the initial guess, which is given with x naught. Say for example, this file is fcnnle1, and I am giving this initial guess as 2, and f0 is the solver of MATLAB. So to the solver, we are giving the file name and the initial guess. So file name is a function name. So this is the function. And here the initial guess is I'm giving as 2. You can also give any other initial guess. Of course, the solution is around the initial guess, because for nonlinear expressions you'll be having, sometimes you'll be having multiple solutions. So whatever the solution you are getting is a solution around that initial guess. Okay, that you should be taking into mind. Say there are two ways. Suppose you can also have this at operator or using this dash. Both are doing the same thing. Of course, the earlier version they were using this way, or I'm not sure of that. Okay, both of the syntax are acceptable. So there is to say about this, you have to have a function name, a function written in a way that f of x equal to 0 form, and give the x initial guess. You will be getting the output, or is the value of x satisfying the equation. So the nice example is our Vander Waals equation solving for the value of v. The Vander Waals equation solving for p or t is very straightforward, as like a ideal gas equation, whereas solving for v is a trial and error solution, because you'll be having 3 roots of v. Obviously, it's a cubic equation. If you try to expand this equation, you'll be having a v of 3 cubic equation. You'll be having 3 roots. So which root is the acceptable one? That and all is your discussion. So I'm giving a solution for this. Say for example, this t and p can take, and r you can have initially assigned, and you can to solve this Vander Waals equation, normally we'll try to solve by using the initial guess from ideal gas equation. So ideal gas is giving an approximate answer. of course, Vander Waals is the a nice model to represent this non-ideality. So we are getting this volume calculated from Vander using the initial guess of value from ideal gas value, which is RT by P. So T and P we are giving from these input statements, and R is already available, A and B are also available, and VIG is now calculated. So this VIG is inputted. So I am getting this output, what is it, estimated, assigned to the variable V Vander. Say for example, you type these codes in a file name, what is called as PVT underscore calculation or any other name. I am having that way. And Vander.m. Say what is this Vander.m? Vander.m is supposed to have these lines. So let us check. F of e equal to, what is it? I am writing this way, RT minus P plus A by V. So you can write in any other way. Otherwise, you can write this way or the RT minus V. I have written that simplest way without any much expansion. So you have this F of V available. We are going to solve for F of E equal to 0. So using the initial guess of ideal gas volume. So this is your ideal gas volume, whereas the Vander Waals equation volume is this way. So this is a simple thing. You can also try to solve using your calculator, using your built-in nonlinear solver available in the calculator, or you can even solve using your Excel. Any of you can say about how to solve this using Excel? Another about maximum 18 minutes available. So we have to see about processing differential equation and some other options. Have you ever tried this option, what is called as goal seek in Excel? Of course, Excel is also good for solving this nonlinear equation. That's the idea of asking this question. Okay, you try that. Now this is about multiple nonlinear equations. So multiple nonlinear equations also simple. So you write the equation in such a way that this f of capital X, what is it? The vector of X, f of X equal to 0. In that way you write. Say we have this X1, X2. So X of 1, X of 2, you write them and they are available in two functions, f of 1 and f of 2. So they are written in such a way that f of 1 and f of 2 are equal to 0. You need to give the starting guess values, no, initial guess value for X1 and X2. The X1 and X2 are given by this, what is it? This array, square bracket, array. Yeah. So 1, 1, or say 1 and 1 are the values for X1 and X2. And it is giving the output. So how do you do this? So always this function file I have, and I'm inputting this to a built-in solver of Matlab, what is called as fsolve. To the fsolve, the file is inputted and the initial guess. Okay, so that and once I press enter, I'm getting this kind of things displayed. It is giving some kind of another thing also. This and all you can try yourself or explore by simply using this fsolve. Or help fsolve will give you many other options. Say the nice example, for example, our thermodynamics. Say for this solving this A and B of Van Laar equation. So this is definitely a nonlinear thing because X. Say suppose you take this left hand side as Y and this is X1 is X, or is Y and X1, X2 are having a lot of other constants like A1 and A2. To evaluate this A1 and A2, we cannot easily do this by hand calculations. We have to use a kind of nonlinear solver. For that, we can use this fsolve. Of course, fsolve and f0 are for solving nonlinear expressions. F0 can handle only one equation, and fsolve can handle one or many equations. That means fsolve is capable of another about 15 minutes. So fsolve is capable of solving multiple nonlinear equations, and f0 is for one equation only. Okay, this example is available. This you can try yourself, and even I have tried to solve this Vander Waals equation for a range of temperature and pressure values. For example, say for 300 and 400 and a temperature of 20, pressure of 20 bar and 30 bar, I need to calculate volumes. Not only you need not restrict to only two values, you can also give a range of temperature and range of pressure, And for every temperature and pressure combination, you'll be getting these volumes calculated. Simply the same set of codes. So what we are doing is we are having this proper usage of dot. Of course, it will take time for me to explain. So at least I will say quickly. See, p plus a dot by v square, v dot square. So this is dot operation. And again, this entire thing multiplied with v minus b. Here we have a dot. So because of that usage of this thing, we can handle array input. So array input or array output, you need to have this proper usage of dot. Or if it is a single data, there is no need for dot. No, that's what we are seeing here. So single data, single temperature and single pressure. So not no need to have any this dot usage. Okay, a lot of nice examples are available from chemical engineering, calculating this terminal settling velocity or pressure drop velocity in pipeline, and very nice problems from our thermodynamics itself, bubble pressure, dew pressure, bubble temperature calculations, or from economics, you can have this rate of return calculations. These are all nice examples for nonlinear equations. And interpolation you can easily do using this interp1, interp2 built-in functions. The x data, y data you have to give as an array, and for what value of x you need to get the y. So that are all nice examples are available here that you try. And I quickly go to this curve fitting and all, you can try yourself. Not much explanation, but non-linear curve fitting slightly explanation is needed. I cannot spend time for this. I'll go to this nice thing, what is called as solving ordinary differential equations. Now ODEs are quite common in representing the dynamics of any system. So single ODE or multiple nonlinear ODEs, ODEs. So how to solve them? You know this numerical technique, what is called as Runge-Kutta operations. So there is a quite common thing, or what is called as fourth order Runge-Kutta method. So the same tool is same algorithm is used in MATLAB as well, using a function what is called as ODE 45 or Runge-Kutta second order thing, Runge-Kutta second order method, what is called as ODE 23. ODE 23 is actually based on Runge-Kutta second order method, and ODE 45 is based on Runge-Kutta fourth order algorithm. So as like any solver, it is asking for the function file, and it is also asking for the initial starting values for x. And in addition, since it is a differential equation, you will also need to know that for what values of the independent variables. So we need to have the time span. Are we starting from 0 to 100 time? You need to get the output values. And any other options if you want to give, you can give. Otherwise, the essential things are these three: the function file and the range of the independent variable and the initial value for the I think x. Okay. So let us see this typical example representing the dynamics of two tanks. We want to find the level variation of tank 1 and tank 2 for any changes in the inflow. These are all connected this way. We have these two equations. We know the initial level of tank 1 and tank 2. So this is the final thing is this problem. We need to solve this. We need to get the value of h as a function of time. Okay, simply to say. So this how these equations are coming simply from your energy balance, mechanical energy balance, there is potential height and kinetic energy. All these things, if you are connecting using Bernoulli equation, you'll be getting this thing. In addition, you also need to use your mass balance. Mass and energy balance will yield these equations. Of course, you can also explore this how these are all coming from your process control, process dynamics course. So we have these equations. These two equations are to be implemented in a function file. So I have this function file 2tank.m. So I'm having this initial value for the h dot, what is called d h by dt, which is initially assigned with 0, 0. Or later you can change from to or is h naught is h1 is 12 and h2 is 7. This input I'm giving in the function in the solution, and h dot is dh by dt or dh1 by dt is 1 minus this thing, h of 1, h of 2. So these are all available here, no? And h of 2 is dh 2 by dt is this way. This is available here. So these are all the lines representing these mathematics. Okay, and MATLAB is taking these function files and the range of values of t starting from 0 to 100. Service 0 to 100. I want to get the value of the H variation. The H is initial height is 12 or 7 for one of the tank or another tank. So I'm using ODE 45, the built-in solver of MATLAB. And for that, function file, the independent variables range, and the initial values of the dependent variable. So the values are calculated and they are available and they are assigned to t and h. And using this plot t comma h, so you are getting these plot commands. Okay, only this much is possible in this time. Another about 5-10 minutes I can give for you people to ask any doubts on the topic we discussed so far. Of course, a lot of other nice features are available. You can explore them maybe quickly to recall. So we have seen the role of semicolon, colon, and dot. So semicolon is to suppressing the echoing of result or end a row, and colon is to specify the range or having the meaning of all, and dot is for element by element operation, and comma is for separating the variables. Of course, that is normally not used. The role of comma is also done by empty space itself. And matrix function we know about, determinant, rank, size, all other things, and plot and log and simultac x, simultac y, other things and all you can try. And algebraic equations you can solve using inverse or f0 or fsolve. F0 and fsolve are for nonlinear equations. If they are capable of solving nonlinear, they can also solve linear as well. Of course, nonlinear things are linearized and solved internally by matrix methods. That is the internal way of solving. And interpolation you can try using interp 1 and 2. I haven't touched upon this. And polyfit for polynomial fitting, and least square curve fitting for any nonlinear thing. And we tried about ODE 45. And even you can see this symbolic mathematics as like a normal mathematics. Say we have this A and B connected this way. We want to solve for A and B. Simply you can input the equations and solve without even representing what is how this matrix is available. We are simply solving as like a normal mathematics class. Okay, so all these things are possible in MATLAB. And in addition, you can also have this Simulink of MATLAB for your process control problems. I feel like this introduction will definitely help you to explore the features of MATLAB. So learning this MATLAB will definitely help you, if not immediately, in your entire career, those for higher studies or for your future work, or at least for taking this kind of class.